So this is a worksheet 3.1 SGI. This was given to us on Friday. You have a green copy of it. And some of you are asking for number 5 because it has a fraction in it, and I'm sure people get confused when they have fractions. Let's first understand that whenever you have a fraction within an equation, you could get rid of it by multiplying everything by the denominator. So what I could do is multiply everything right here by 2. That way this becomes a 4, this becomes a regular y, it cancels out, and this becomes an 8. But before doing that, we know that we're doing linear combinations or elimination method. So if I combine the 4 and the 2x, they don't eliminate. If I combine these guys, they don't eliminate. So let's kill 2 birds with 1 stone. Let's get rid of this fraction by multiplying everything by 2. But if I wanted to cancel with a negative y, what do I need to have right here? Positive y. So the top one, I'm going to leave it the same. All I'm going to do is write it over here on the side. And the bottom one, we said we're going to multiply it by 2, but not only by 2, we're also going to multiply it by a negative 2. That way, the negative 2 times negative y over 2, the negative and the negative become positive, and the 2's cancel, so you'll end up with a positive y right here that'll cancel out with the negative y. So let's do this slowly. Let's go negative 2 times positive 2, that's going to be a negative 4x. Negative 2 times negative y over 2, that's going to be, if you do the work on the side, negative 2 times negative y over 2. Yeah, the 2 on top cancels with the 2 on the bottom, and you have a negative times a negative, which ends up being a positive y. So that's why I put plus y over here, equals negative 2 times 4, that's going to be a negative 8. And I hope everybody understands that, yeah? Let me erase this right here. Let me also erase all these lines up here. Okay, so now I'm able to combine the lines. The 4 and the negative 4x cancel out. The negative y and the positive y, that's weird, it canceled out also. So the equal sign is coming right down. On the left side, I really don't have anything. I have 0 because everything canceled. On the right side, I have a negative 2 because 6 minus 8 is negative 2. So that right there is no solution. No solution. Or you could do this. So we're going to check out number 7. And number 7, we also have a fraction right there. So listen up, guys. Would you like to get rid of the x's or the y's? You probably want to get rid of the y's because of the fraction, right? How about this? Let's just first start by getting rid of the fraction. How do you get rid of the fraction? We'll worry about eliminating a variable later, but how do you get rid of a fraction? Multiplying everything by what in this case? Multiplying by 2. So the top one I'm going to leave the same. I'm just going to write it over here to the right. Leave it exactly the same. There it is, 2x plus y equals 8. And the bottom one, when I distribute, I'm going to distribute with the arrows underneath so it doesn't make a mess. 2 times 3x, that's 6x. 2 times 3 halves. What happens there? The 2 and the 2, this 2 out here and this 2 down there cancel out. So what do I have left? 3y. Because the 2 cancel with the 2. It's just 3y left over. And now finally, 2 times 12, that's 24. Okay. Now, in this case, it's still not ready to combine and cancel. So this is like our new system that doesn't have any more fractions in it. Okay, so what would you do now? You want to get either the x's to eliminate or the y's to eliminate. What do you do next? X's, okay. So what would I have to multiply the top by in order? A negative 3, that's right. So let's put a parentheses around the top one, and let's put a negative 3 right in front. And let's actually show that we're going to distribute that negative 3 times 2x, negative 3 times y, negative 3 times 8. And let me rewrite my top equation down here. Negative 3 times 2x is negative. Okay, we'll get there. So negative 3 times y is negative 3y. Negative 3 times 8 over there is negative 24. And on the bottom, we're just going to rewrite it. 6x plus 3y equals 24. And as you could see, everything, this cancels, even this cancels, everything cancels out when we combine the lines. So you really have 0 equals 0. Is that a true statement?
No.
Yes, it is. 0 always equals 0. It always equals 0. So this is always true. In other words, your variables, both variables completely canceled out. It doesn't matter what x or y is because 0 always equals 0. So right there you would say infinitely many solutions. I'll let you abbreviate IMS, but other math teachers probably have you write it out. Infinitely many solutions.